Welcome. I'll get back to me shortly.
All yours.
Thank you, sir.
Yeah, I'm gonna sit over here. That way I can listen to that meeting. Will you do me a favor? Will you silence over here?
CLEAResult is
Good morning. Thanks for joining the webinar here. We'll wait a couple minutes here and let everyone else join. Morning. I'll give another few seconds here to let more people to join, and I'll get kicked off with a couple of introductions. All right, and I'm assuming everyone could see my screen here with the intro slide. Awesome. Thank you. All right, I'll get us going here. 11:01. I know we'll be filling up the hour, so I'll kick us off by welcoming everyone to the Heating Solutions for Commercial Buildings webinar. As a quick reminder, or introduction, sorry, not reminder. My name is Kelly Lewis. I'm the Associate Program Manager here at CLEAResult, and we are considered the third-party implementer for the City of Palo Alto Utilities Business Energy Advisor and Business Electrification Technical Assistance Program. I'm joined by Sarah Rankin, the account manager for the rebate programs, and Steve Brennan, our talented and knowledgeable engineering manager, who will be presenting today's webinar. And lastly, Shelby Sinkler, who is the sustainability program manager at CPAU. And I know Shelby has a couple of slides that she has prepared and wanted to share with you all here before kicking it off to Steve.
Good morning, everyone. Thank you, Kelly. And we could go to thank you. So I'm just going to introduce the City of Palo Alto and talk a little bit about our programs quickly, and then pass it off to Steve. So I'm Shelby Sinkler. I'm the program manager for our Business Energy Advisor, Business Electrification Technical Assistance Program, and our Business Customer Rebates. So a little bit about CPAU. We are a small municipally owned utility, so that means we are owned by the City of Palo Alto. We have about 30,000 customers that we serve, and we provide all utilities, including water, wastewater, electric, gas, storm drain, and fiber. We've been around for over 100 years, and as some of you may have heard, we have pretty aggressive sustainability and climate action plan goals, and these programs that we work on alongside CLEAResult help address our goals there. So here's my contact information on this slide. I know we're going through this pretty quickly, so we can always give this to you at the end, and feel free to reach out if you have any questions about these programs. Next slide, please. So a little background on what we do with CLEAResult. The Business Energy Advisor is a free energy efficiency and water conservation program where we can come to your business and do a free assessment. We'll provide you a report with all of the different opportunities for energy and water savings. We'll provide you potential project costs and also rebates available to you. This is available to all small and medium businesses, so ideally around or under 50,000 square feet. We do have a larger commercial efficiency program if you are interested too, that we could always point you to. But the Business Electrification program is very similar to the Business Energy Advisor. We do a free assessment and provide you a report. But with this, we'll provide ongoing technical assistance with all electrification projects. And if you're not familiar with what electrification is, that is switching off of natural gas and switching over to efficient electric alternatives, usually with water heating, some kitchen equipment, and HVAC as well. We are currently offering a limited time boosted incentive for heat pump HVAC systems. So I know Steve's going to get into our rebates a little bit in the early on slides in his portion of the presentation, so I won't get into it too much, but just know if that's something you're interested in, to reach out to any of us and we'll be happy to help. I'll go ahead and pass it off to Steve now. Thank you.
Hello, everyone. My name is Steve Brennan. I'm an engineering manager here in California. I have a team of engineers in the area. I'm going to go ahead and share my screen just so I can control the pace. So I apologize. I just got to get that set up.
And I'm seeing your background, Steve, but you seem to be not pictured.
Any better?
There you go. Yeah, good to see you.
Let me share my screen.
All right.
Now we should be back to where we left off with Sarah. Today I'd like to talk about heating primarily and how to address heating. You know, this is in commercial buildings and how we move forward with changing from a gas-based heating system to an electric heating system. So that'll involve reviewing heat pump operations, looking at the heating commercial buildings. There will be some you know, review of previous presentations because a lot of this material is still relevant. And then we're going to talk about how to implement heat pump solutions and even some of the more complex solutions we've only mentioned briefly in the past. I'm going to turn my camera off to maximize my bandwidth. We'll talk about the savings rebates and the benefits and challenges. And there'll be a slight change to some of these items. Before we might mention some, you know, minor obstacle, we're going to talk about how we overcome those obstacles and some of the benefits we can reap from some of these products. So the electrification program, this is the catalog from Palo Alto. There are $3,500 per ton limited time boosted incentives for electrification on package split systems. Those incentives will not exceed the cost of installation. So if we determine that you have a 10-ton system at $35,000 potential rebate and you spend $20,000 replacing it, it'll only achieve a $20,000 rebate. The heat pump water heaters for the different sizes have different levels, and and then we can calculate. There's a couple of kitchen items up here: convection ovens and electrification fryers. We can do custom products that are not listed on these 2 pages, such as boilers, full water heaters, etc. So you'd have to reach out to us directly to do custom projects, and we can calculate a rebate based on that. So in the past, we just looked at the package heat pump. We're also going to look at the heat pump water heater and some custom solutions here. This is again contrasting. The left side shows all the available measures through the audit program. This is the available measures that are listed through the electrification program, but don't let the short list fool you because custom can encompass quite a few different things. Just a quick review. We wanted to start at the air conditioner, which everybody's familiar with. This also applies to a refrigerator. It's the same thing. This is the refrigeration cycle we all deal with. The evaporator pulls heat out of an airstream, and the condenser exhausts it outdoors, or in the case of your refrigerator, onto your feet when you're standing in front of it. Feel the warm air blowing out from your refrigerator. And so this is just the standard. We have a compressor, we have an expansion device. The evaporator sucks up the heat. Now, the only difference between that and a heat pump is the heat pump is reversible, meaning that we can switch the location of that evaporator and condenser and use it for heating as well. So no longer do we have an air conditioning system like up here that only sucks heat out of a space and puts heat into another space, or, you know, it's meant to cool a space. Now you can also heat a space by just flipping the condenser and evaporator. It looks like this. Cooling cycle, summer operation. We're expelling heat outdoors and you know, drawing heat into the coil indoors, providing cool air, and it's vice versa. A good system will have 2 expansion devices so that it's more efficient. The thing to note is during the heating cycle, during heating season, you are trying to exhaust cold air. You're trying to pull heat out of cold outdoor air. During the summer, you're trying to exhaust heat out into the hot outdoor air. And so we're pumping heat from one space to another, and it's against nature. It really is, because if it's hot outside, by equilibrium, it wants to be hot inside, and we're fighting that with electricity. The more efficiently we do that, the more efficient the equipment we choose, the better off we are. Might get really noisy here. I hear the garbage truck showing up. The heat pump water heaters operate on the same principle. On the left, you have a straight heat pump water heater. The condenser is in the water, and the evaporator is up here, pulling heat out of the surrounding air or the air passing through here and putting it into the water. It's a one-way. This is not a reversible process. You don't have a chiller here, on demand. This is strictly a water heater. And so one of the tricks is that, say you have this as an outdoor closet, you're pulling, in the wintertime, you're pulling heat out of very cold air. And recovery time becomes an issue. And so what they've started to do, and it's become very popular, is provide hybrid water heaters, hybrid heat pump water heaters. You'll find them everywhere, Home Depot, Lowe's. And they have elements, just like an electric water heater, provided, and they're programmed into the controls to only come on when it's absolutely necessary. So you can still achieve a very high EUF or efficiency on a hybrid water heater, even though it has the supplemental heat. But it gives you that ability to have quicker recovery, so that the water doesn't run out. The hot water doesn't run out. It takes 3 days to heat the tank up again. It's not going to happen. For one thing, it's designed not to happen. But for the other, if 3 people take a shower, those elements are going to kick in to make sure that when you go to do the dishes, you still have hot water. So the hybrid is kind of hedging the bet on the heat pumps, yet still achieving a very, very high efficiency. So heating commercial buildings, just the methodology has always been, you throw a gas heater on of some sort. There's a high efficiency gas heater. You can see the PVC exhaust pipes. And you throw an air conditioning coil, and here's your outdoor unit. So the coil's hiding in this box down here, and the unit heats with gas and it cools with electricity. We're trying to get away from gas. And here's a package systems, same thing. These, you can see the gas lines running up into all these units. See these squiggly lines? Those are the gas lines running in. And the compressors, the air conditioning, it's the same principle. It's just that now the air is being brought up into the unit and discharged down through. Whereas before we had a remote unit. This air conditioner was remote, maybe. This is a split system. These are package systems. So once again, these systems can range from the medium small, I would say 4 tons, 3 tons might be the smallest you find, to the very large, 100 tons plus. A ton is 1,200 BTUs of cooling. A ton of ice. It's the amount of energy it takes to melt a ton of ice. And that's because that's how they used to cool buildings. It's a very interesting story. So your typical package and split CAV systems, constant air volume systems are just going to push air with a single speed most of the time. You very seldom have a variable speed fan. And it delivers the hot or cold air and recycles the air up and out. In this case, it's going to pull in some fresh air. In this case, it will not. That's something to keep in mind because you need fresh air for Title 24 in the state of California. Split systems, you have to run a duct in there to get fresh air. But the point is that whether you have one space or multiple spaces, you're discharging air into all of those spaces and returning air from some of those spaces. This one maybe doesn't have a return. Now, the challenge that may bring up is, and this is something we'll cover later, is there's only one thermostat here. And if this person wants to come in and work, they have to come in and turn on the thermostat to heat the entire building to turn on this unit because there is no variable air volume. There is no dampers shutting off the spaces. So they said, well, that's not a very good design. Let's design something a little more complex that will do that. And that's where the VAV design came in. These are usually on multi-story buildings. I've seen them on larger single-story. The air is conditioned and delivered to a box, which might hit 3 spaces here, like it's showing, or it might have 1 box per space, depending on how large the spaces are. And so you'll have a boiler in the system that will reheat the air. And so you're cooling the air to the least common denominator. The person needs the most cooling, and then reheating for all the other spaces that are either satisfied or need some heating. If it sounds inefficient, it's because it is, but it was the best solution at the time when they came up with it, and gas was very, very cheap at the time. And so heating water and circulating it was considered a no-brainer. And it's still in wide use today. It still gets designed into new buildings today. Our new control systems are more efficient, more sophisticated, and can make it more efficient, but there are still issues. So you see the big boiler plant here, a gas boiler plant on the roof. Once again, we're using gas to heat. And there's atypical systems. I don't want to delve into them too deep, but there are radiant systems, wall space heaters, furnaces. And then there's challenges that come with any of these systems. Stratification is when you have a high ceiling space or a tall building and the heat wants to suck to the top. The heat wants to rise. And the hotter the air of the discharge, which is typical of gas-fired equipment, the more stratification you're going to get. Distribution, the poor airflows. If your constant air volume system was set up 20 years ago and you've reconfigured your space, you may have to have somebody come in and rebalance the system because the distribution's been messed up. Consistency. There's also limited thermostats. You have 4 or 5 spaces off the same thermostat. What's happening near that thermostat? That could affect everybody. Recovery time. How quickly can that heating system heat up your building? If it's a very slow recovery time and you forget to set it to start at 3 a.m., then you may not have a comfort that you want when you arrive at 7 a.m. Air quality. If you're burning gas, you're creating pollution. And sometimes that pollution ends up in the house, especially with wall furnaces and some other items. Thermostat. Do you have an old dial thermostat, or do you have something that's at least, a 2.5 thermostat that you can program weekends and weekdays separately? The GHG impact of that, of the gas being burned. So even if it's not affecting the air quality inside the building, it's going to affect the carbon footprint of the building. And then leaks that you might experience in hydronic systems where you're running hot water everywhere. Now, the issue with stratification, again, is that the hot air is going to suck to the top. And destratification means you want to put in like ceiling fans or some sort of blower that's going to mix that air back down. Less of an issue with heat pumps because the discharge air is going to be at a lower temperature most of the time than a gas furnace. Gas furnaces are brute force. They're going to deliver very warm air. Another item is space heaters. They're ubiquitous. People they feel cold, they throw a space heater under their desk. The impact of that can be that if the person near the thermostat decides that they're just not warm enough and they throw a heater under their desk, they're going to shut down they're going to basically kick the unit into cooling, and everybody else on the floor is going to freeze. Same thing if you put a copier or a fax machine under this thermostat. So direct impacts on the thermostat that's affecting multiple spaces is something we need to consider when we're heating a space. Now, with heat pump solutions, as we discussed before, we have the smaller units like window units and through the wall you'd see in a hotel. Here we have the medium-sized units I showed you, some splits and package. We have multi-head systems I'll show in a few slides, VRF systems I'll go over, and then larger systems. And the larger systems typically are VAV systems, not always. Sometimes it's a hydronic boiler feeding hydronic floors or something, and large rooftop package units, this constant air volume. Those can be quite large if the engineer determines that you don't need variable air. This space is always going to have the same load or work together. So the split heat pumps, again, pretty easy to retrofit because you're just running refrigerant lines and electricity. Doing a package unit where you don't have a package unit before means you have to put in all the ducts now, and that's not easy. So this is a very popular way of retrofitting, usually cooling, but these are heating and cooling systems. And so you might be replacing like some wall heater. You put this thing in, it's going to give you heating and cooling. So split heat pumps are very popular. They also come in a couple different flavors. They come in a single head and a multi-head. So this one condenser unit or outdoor unit, we're talking heat pumps, got to change my vocabulary, can operate multiple spaces. And those spaces might have built-in thermostats, they might have wall thermostats, but the point is that these heat pumps can easily be retrofitted into buildings that don't currently have ductwork or don't have, functional systems. Now, again, we go back to the same, this is the same graphic as before, and we're talking about split heat pumps and rooftop package heat pumps. Once again, it's a 1-for-1 switch most of the time. So if you have a gas package unit, you can usually find a heat pump package unit that will do the same thing, and you don't have to change much of the rest of the things, of like thermostats, wiring, ductwork. It's all the same. Same here. You can find a unit that will replace this indoor unit and a unit that will replace the outdoor unit. So the gas unit goes away. You have an air handler in here. It talks to the heat pump. And once again, it's a 1-for-1 swap. These are usually pretty simple. Where it gets a little more complex is when you want to do like a variable refrigerant volume or variable refrigerant flow system. And these systems, you're not going to already have this and go back to it. This is a new system. And so this is a solution for some of the buildings where you have different needs in different spaces. And if one space is always needing cooling, another space is always needing heating, this unit will harvest the heat out of the space you're cooling and put it in the space you're heating. Very, very high efficiency, very popular product, especially up here where I live in Tahoe. There more and more of these are going in because of that harvest and trade. It just really jacks the efficiency up. But what I really want to talk to you guys about today was solutions for the complex buildings. People say, oh, well, 1-for-1. I've got a boxcar on the roof. It shows it on the first floor here, but they're usually on the roof. I got a boxcar and a boiler on the roof. The boxcar cools, the boiler heats. I distribute cool air everywhere, and I reheat it where I need to. Why don't I just switch everything? And the answer is there's a couple reasons. One, the inherent inefficiencies we discussed earlier, in that you're cooling air, then you're reheating it, is inefficient. You don't want to do that any more than you absolutely have to. And so just slapping a new boiler and slapping a new air handler on there, you're going to end up with an inefficient system. And you don't want that with heat pumps. Heat pumps are inherently more expensive to purchase and install. And you're putting, it's like, what was the analogy? Putting expensive solar power on a building that wastes a lot of electricity, right? You want to fix those wastes before you size your solar array. Same thing here. You want to fix the inefficiencies before you size the boiler. And so I might go into a building, and this is a real example, and find a 1,000,000 BTU boiler. And then after some optimization and some study, put in a 250,000 BTU heat pump boiler because we fixed some of the items. And this is how we would fix it. We start off by optimizing the system. And the reality is you can do this to any VAV building. And without any thought towards electrification, it's still going to get you energy savings. We're looking at, is that cooling only unit on the roof, can we replace it with a heating and cooling unit? So in the wintertime, I can provide warm air, and then that's going to reduce the amount of reheat I'm going to do in the wintertime. Because before they thought, it's cheap gas. Why don't we just distribute hot water everywhere and reheat is no problem? Well, reheat's a problem now. We want to do it as little as possible. So can I replace that rooftop unit with an efficient heat pump that heats and cools? Problem one solved. I can raise that delivered supply air temperature. But are my controls sophisticated enough to do the next steps, to really really crank down on the waste in this building? And then we want to look at the control system. Are the sensors still within calibration? Do we have those hot water valves that should shut off when there's no more heating call in those spaces? Are they actually shutting off? Because if I have a hot water valve that shuts, but all the guts of it are shot, the hot water is still flowing, now my air conditioner has to work harder. And so can I fix these things and repair and just make sure my whole system's up to speed and running? Then the next item is I need to look and see if the sequences that operate these different spaces, the VAV sequence, the air handler sequence, do they make sense? And what changes am I going to, what changes can I make to get them to the latest and greatest sequences, the best? And then once I've done all that, and I'm pretty happy with the system the way it's running, I run a study. And this is what I need to find out. Do I have a bunch of spaces where the hot water valves are always open? They're just always open, maybe up to 100%. And do I have places where the dampers are always open and the hot water valves are closed? And what that's going to tell me is, are there spaces controlling the needed supply air temperature? Like if I always need cooling in this one space, say I moved a data center into this one space, and I always need cooling in that space, that's going to make it so my entire system has to run on 55-degree air, and the whole building has to reheat that air up to 70 degrees in the wintertime. Well, that's a waste. There's no way that makes any sense. But this study is going to inform me, and this is all just optimization. This study right here will inform me for the next step, which is the capital improvements. Now, the first capital improvement, once again, would save you a ton of energy regardless of whether we can do electrification. Actually, it's not the first improvement. It's number two here. And that is if I need to put something in that data center that's going to cool it in the wintertime and then take it off of the VAV system so it can run a higher supply air temperature and do less reheat. And I address any areas that need cooling year round like that. That's kind of a strategy. So we're spending money now though, because I'm putting in like a mini split system or something to address the cooling, or a CRAC, computer room air conditioner, to address the heat loads in spaces that are atypical of the rest of the building. Then I go back to bullet 1 and I'm replacing that RTU on the roof, the big unit on the roof that's supplying the air. And now that I've done that, it looks like I have the study on here twice. I'm going to address I've addressed the issues of the hottest and coldest spaces. And then I need to double check that my hot water needs have been absolutely reduced to the minimum necessary. And now I've shrunken the boiler needs down from maybe 1 million to 250,000 BTUs. And my installation cost has just dropped dramatically. These are very scalable on the size. And I have a building that's running much, much more efficiently. So before I even switch out the rooftop unit, before I even switch out the boiler, I'm already addressing inefficiencies and waste in the building. And it benefits everybody. One thing we should mention, though, we're talking about heat pump water heaters, and one of the byproducts of a heat pump water heater that we haven't mentioned yet is they are unidirectional. They are always discharging cold air. They always would like to have warm air going into them. And so when you think about that, we just had a conversation about a data center, a space that always needs cooling year round, and it's screwing up the rest of the building. These units can be harnessed to try to, provide cooling to those spaces that always need it, but also to pull the heat. These things are going to perform better with the warmer air that's provided to them. So if you're pulling it out of a warmer room, say a data center, and blowing it through here and putting it back into the data center, you're taking cooling load off of that data center, and you're getting better quality heat in your heat pump. So just a thought, ducting, installing them adjacent, but harvesting the cold air and the cooling that's happening in the head of this heat pump is something to think about. So this lock-in bar on the left, I believe this is a non-hybrid. I believe this is a straight heat pump. It has the potential to be converted to a hybrid, but this is just a lock-in bar is one of my favorite brands. When I was a facilities director, this company, regardless who they license their equipment from, has the most reliable, highest efficiency equipment we were able to get for the cold climate I live in. And all of the facilities around here will not use anything but their products now. So they're highly reliable. Found in the Bay Area too. This is a Rheem hybrid. This is a high efficiency hybrid, 3.75, I believe, EUF, which is the highest we incentivize. And this is just I want to say Home Depot. It's just, you get it at Home Depot. I think it's $1,600, and they claim a $375 a year savings. It's converting from gas. And then this is a split system. So once again, I have a condenser. It's a water condenser inside this tank, but I put this in outdoors. So I'm using outdoor air or something else. I use computer room air, whatever. But I put this outside of the space that I have the tank in, or outside of the building, put the tank inside. Very beneficial because they're having complaints, not with these two brands, but they're having complaints about noise from heat pumps, heat pump water heaters, and this would put the noise outside. So that's kind of a nice solution there. Any questions on the heating, the stuff we've talked about? I blasted through it pretty
Hi,
quick.
Steve. Steve, I have a question. On the previous slide, did I hear you say that an HVAC heat pump installation could reduce energy usage from 1 million BTU to 250,000 BTU? And
No, it's optimization.
okay.
Optimization of the system
Okay.
can possibly result in a great reduction of the hot water delivery due to the inherently inefficient design of single duct VAV systems.
Okay. Okay.
Yeah, it's
All
not
right.
the heat pump; it's the optimization. The heat
Ah,
we optimize first to downsize the.
yeah. Yeah.
You could
Okay.
downsize to a gas furnace.
Efficiency first.
Efficiency first.
Yep.
Efficiency
Always.
first.
Okay.
Yeah.
Thank you.
Absolutely.
I have a question, if we can ask.
Sure.
Yeah, so I was unclear on one thing. So we own an older commercial building, and it's got a furnace and circulates hot air and cool air, et cetera. If we replace all of that with a heat pump, does anything else need to happen to all that air ducting and all that, or is the heat pump just a drop-in replacement for the furnace and the air conditioner?
If it's a ducted unit with none of these dampers, with no VAV boxes, if it looks more like this, it's pretty much a drop-in replacement. Do you know if your furnace and your air conditioner or your air handler are separate, or is it a package unit on the roof?
They're separate. There's an air conditioner and a furnace.
So the furnace is indoors and the air conditioner outdoor unit is outdoors with coil indoors?
The furnace is indoors. The air conditioner is on the roof. I didn't catch the last one.
Like this one. Yeah, and so that's pretty much a straight replacement. In fact, the outdoor unit might look identical to the one that you currently have. A lot of manufacturers are finding that they can use the same structure for their outdoor units on their heat pumps because the only difference is the valves that reverse. So you
Got it. But the ducting doesn't have to be like pulled out and completely replaced in all our offices or anything like that. Okay, got it.
No, typically it's the same unless there's a drastic difference. Like say you were in Alaska and your winters were very, very cold and you were used to delivering 140-degree air from a gas furnace and your new heat pump's going to deliver 105-degree air, you might have to upside the ducts. But we're in Palo Alto, you're probably just fine.
Got it. Thank you very much.
One thing, it brings up a really good question though, and that is that, can I set my air conditioner back at night the same way I do currently? And what a lot of people, not air conditioner, heat pump. And what a lot of people have found that it's not the case. Not if you want to stay away from that supplemental heat. And that's something we didn't talk about much today, but a lot of heat pumps come with a supplemental heat. And all it would be is like basically a resistance heater just stuck in the duct right here for the same reason we have those elements in the water heaters. And we want to avoid using those as much as possible because any use of those will drop our efficiency. And so try to oversize things a bit for the cooling load up here, for the heating load up here. And then you want to keep your setback very small because the heat pump, when it's 20 degrees outside, that heat pump may be able to maintain your space, maintain the amount of heat your building's losing and put that back in, but it may not be able to recover it. So if you set it back 10 or 15 degrees, and you come in the morning, that heat pump's going to be trying real hard. It's going to need that supplemental heat to get you back up. And so what they found is the people who either keep it constant or drop it back 1 or 2 degrees for the nighttime, what they'll find is that those the efficiency, the energy use of those buildings will be far lower than somebody who actually steps it back. It's counterintuitive because your gas heater has such an easy time recovering a building. It's so oversized. We can't do that with the heat pump as easily. So just something to keep in mind. Again, you're not in an extreme climate down there like we are, but it's something to keep in mind. You might have to play with your setback and your scheduling to see how long it takes to achieve that comfort. And where you used to have it kick on at 7:30 for an 8 a.m. start day, you might have to kick it on at 5:30. And then your nighttime temperature, instead of being 58 degrees, might be 65. So just some things to consider. And one of the points we didn't make was that these heat pumps are generally 3.5 times more efficient than resistance heat. So when people hesitate to run it all night to try to keep the building, it's actually quite efficient to do. It's more efficient to maintain the building with the heat pump than to recover the building with supplemental heat, resistance heat. Any other questions, comments, anecdotes? All right, I am going to move on to the next slide. I think this is an interesting solution. I'll mention it one more time. Because this is a separate unit and you don't like water near your electricity generally, people might say it's not okay to co-locate a heat pump water heater in a data center, but you can put the condenser in there, or the evaporator in there. That would remove the water completely. You'd have refrigerant lines running to here. It would be working in a warm environment. And as a lot of you may know, they've been raising the recommended temperature of data centers. The old crusty guys will say, I'm one of them, will say, oh, you got to have it at 55 degrees because that's what they were taught in 1985, 1986. The newer systems are designed to operate at higher temperatures, and every degree of temperature you can raise that's less cooling you have to do. Well, the warmer that space is, the better this unit's going to function, because now you have heat to pull out of the air. When it's 20 degrees outside, it's 75 in there, 80 degrees in there. Now you have heat you can pull out of the air and put into that water if you have a decent hot water load. So something to consider. These split systems are actually quite exciting. Okay, next step is to talk about efficiency, savings, and rebates. This is the limited time. It's quite a big jump, so I would recommend people jump on it. We have a lot of different ways of measuring efficiency, and we're always adapting to it because it's always changing. Right here we have the old SEER rating. It's now SEER 2, but a lot of people are still using SEER, and the state work papers still use it. So hopefully they'll adapt soon. Products that are delivered today usually have both listed, and we try to accommodate. We do have a lot of equipment being delivered that has a low EER, energy efficiency ratio, that is like, wow, that's too low, but a very high IER, which is one that takes into account different seasons and stuff. And so we are going to go with the one that makes the most sense. This is a much more precise version of measurement of efficiency, so that's what we're going to stick with. If a product comes in with a low EER and a high IER, we're going to go with the IER. You'll get the rebate on that, based on that. These are the minimum thresholds for any rebate. If you go below 15, there's no rebate on the SEER. And that's because that's code minimum. You can't buy something. Well, that's not true. Let me think about this. 14 is the code minimum. 15 means you're going above. So therefore you get a rebate. 16, you get a better rebate. 17, you get it even better. And so this is the minimum. These are the minimum qualified rebates. different sizes. So we're talking, this is the big stuff. So very excited pilot program that's going on right now. Very excited. And then the water heaters, we have different rebates, and we have different tiers, and the tiers will affect the savings, and so how quickly you're going to pay off that product, you know, in your I mean, you might pay it off with the rebates, but the point is that it's going to save you, each tier you go up is going to save you more energy every year. So real quick, we want to talk about the benefits and challenges because, as I said, there are going to be challenges with these. The benefits is, and this is kind of a holdover. When you take out a furnace and put in a heat pump and you didn't have air conditioning, now you do. That's kind of nice. Lower energy bills. This is kind of a nice feature. If you're using your system correctly, you're getting the good efficiency. And your carbon footprint's being reduced. We're getting rid of gas use. And one thing to note about gas use in a commercial building is the lower you go, the more you're going to pay for the gas because you're paying a flat fee every month, and then you're paying a fee per therm. And so we recently had a project where they used very, very, very little over a 3-year period, but they paid thousands of dollars because they still had the gas. So get rid of the gas if you can. We want you to convert everything to gas. If it turns out you're converting your furnace on the roof, but you're keeping your gas water heater that you hardly use, that's going to be some really expensive gas for that water heater. And so, but the fact is that should push you towards that zero carbon if we can, the footprint for your site. That's really what we want to go for. Get rid of all the gas. Lower stratification in the taller spaces because we're delivering a cooler warm air than the gas, and then eliminating that gas service. That's just redundant. Now the challenge is, if you had the furnace and you're going to an air conditioner, you never had an air conditioner, you're going to a heat pump, you could be paying to upgrade your electrical system. You're adding a 20, 30, 40 amp service or breaker for that new unit on the roof. If you already had air conditioning, don't sweat it. That air conditioning breaker is probably going to serve your heat pump just fine, 99% of the time. Now, the VAV system and boiler skids are a challenge. We talked about the challenge. It's not a small process. It's not a one-for-one drop-in, and that's kind of can be a headache. But we have a solution, and it will result in overall more efficient building operation. So, you know, we are working towards that solution. Cold climate operation can be very tricky. We have situations where a contractor will put in a heat pump and then just slap on 10 kilowatts of supplemental heat, and then he'll program the thermostat and walk away, and then they come to us and say, "Hey, how come my energy bills went up so high?" It's like, because you basically have a space heater in your wall. You're not using the heat pump because they didn't install it right. They didn't program it right. But that aside, in the cold climate, because that could happen anywhere, you're trying to draw heat in from the outdoor air, and it's 10 degrees outside. There's not a lot of heat in that air. And so there are some real challenges to cold climate operation. We had a fun one if your reheat circuit, because it'll do a melt circuit on the outdoors because you can get ice building up on your coils. And so it should go through a melt cycle every couple hours. If that breaks, you get a big old beach ball of ice on your air handler. I've only seen it happen once, and it was on a barred unit on a portable classroom, but it was quite interesting. The cold climate up here in Tahoe, very challenging. And then the supplemental heat impact, as I mentioned before, it can really hurt your efficiency. Some studies have shown it'll drop it right down to 1, where we're typically targeting a 3.5 COP. So with the water heaters, again, we want to lower the energy bills. We want to lower the carbon footprint. These are our benefits. And we can eliminate the gas service, all similar items to the previous slide. But the chilled air exhaust can be used to cool spaces that always require cooling. Very interesting potential here for reducing some cooling loads. And then the challenge is you have chilled air exhaust. If I put one of these in my laundry room, it would be freezing down there because it's always going to try to be pulling heat out of the space that it's in. If I put it in an outdoor closet, now I got 5-degree air trying to go through there. Not great. That's a cold climate operation item. If you're in the cold climate and you have an outdoor unit, it's going to be hard to find the heat in that air to pull it out. And then the supplemental heat impact. Luckily, these are contained systems, whereas a package heat pump, or not a package, but like a heat pump, for space heating, is going to have a vendor configuring it. This comes configured. And so achieving the efficiencies that are on the box, that are on the cut sheet, are much more easier to achieve, but you're still using resistance heat. And so putting an undersized heat pump in a space where you have a bunch of like middle school kids taking showers and stuff, that supplemental heat will be off the chart. Your efficiencies are going to be garbage. And so you really got to tune into, how do I keep using the heat pump and not using that supplemental heat? What do I need to do? Is it a storage tank? Is it a second heat pump, etc.? So these are some of our challenges. And that leads me to the questions slide. Anybody have any questions, comments, observations? All right.
I guess I'll ask them. So how do you get started on all this?
The beginning is the audit. We'll typically do a site walk for your property, and we do 2 reports out of that. If you're under 50,000 square feet, if you're over 50,000, you only get the electrification report. It will identify the potential measures, like, oh, this is a good candidate for a heat pump, this is a good candidate for a water heater, heat pump, etc., and give you an idea of what the costs and paybacks, etc., would be. And then from there, you'd work with Shelby's on here. Do they work directly with you, Shelby, or what's the next step past having an audit report in their hands, or an electrification report?
Yeah. So for an electrification report, you can just email that email address that's on the screen right now, the business energy advisor at cityofpaloalto.org. You could call that number. You could also email me directly. I put my email in the chat, shelby.sinkler@cityofpaloalto.org. So yeah, we can set you up. We'll get you scheduled with the engineers to come out. Usually they'll be able to come out within a week or so. And then, yeah, we'll get the report to you a couple weeks later.
And but after they have the report in hand, how do they move forward to the next step where they actually are trying to get the rebates and replace their heat pump?
Yeah, so the customer will have to get bids. If you have a contractor that you already work with, that's great. If not, we usually recommend customers get 2 or 3 bids to compare. And then we can also assist with reviewing those and seeing what proposals are the best offer for you. And then from there, you just do the installation. You will have to get a city permit. And again, if there's any questions with that, we could guide you through that process as well. And then once the project is complete, we will provide you with your rebate. There is one thing I want to mention about the boosted HVAC rebates. We are doing milestone payments. Since this is a pilot program, this is the only rebate we actually give a milestone payment for. So we'll give you a portion of it when you purchase the equipment and get your permit at the beginning of the process. And then we'll provide the remaining amount at the end once the installation is complete.
Thank you, Shelby. And one thing I would like to mention on top of that is that when you go out to bid for your, you're trying to find a vendor to install the heat pump, don't just say, hey, I want a heat pump. Look at your audit report or your electrification report and say, I need a heat pump that's better than 17 SEER or better than 18 SEER. You really want to be specific, because what will happen is you'll get a bunch of bids where they're doing code minimum heat pumps, like 15, 14 SEER heat pumps. And that's not going to get you a rebate. The rebates are based on the efficiency above code minimum, which is 14. So a 17 SEER is going to get you a bigger rebate than, well, no, I'm sorry. I keep thinking, I do 2 programs here with Palo Alto. They'll get you better savings. We have kind of a premium on the rebate right now, but the savings are very, very determined by the SEER rating, and below a certain point, you won't even get a rebate. The rebates go away. So be very careful about what SEER rating they're proposing, because we can eliminate we typically eliminate more than half the bidding vendors based on the low SEER rates.
So question about that. Sorry, go ahead.
Oh, no, I was just going to add to what Steve said. That's one really important point about the SEER rating. Usually myself or Steve or someone on the team will review the bids with the customer and look into the model that they propose. And if anything comes up, this has happened with a customer in the past where they ended up changing the equipment because it was unavailable by the time that they needed to install. Please keep us in the loop on that as well. There's tons of options out there, so it's usually pretty easy to find another option instead.
Yeah, don't get talked into it.
Can we ask you to introduce yourself, because on the screen it's showing up as H?
Oh, sorry. So my name is Hugh. We own a small commercial office building in the downtown area. What else can I say?
Yeah, I mean, for anyone that's interested, please reach out to Shelby. She is the lead on our, rebates, but also this boosted incentive, which is a great opportunity for people that are looking to make the switch. We have, there are certain guidelines that customers need to follow, and it's only for up to 10 customers. And we already have 2 that are enrolled. And so if you're interested, please reach out.
Question about that. Is that program intended for a certain size building or site where you guys give preference, let's say, to larger or smaller operations?
No, it's not limited to any square footage or anything like that. The only limitation is that there is a rebate cap of $120,000 or the total cost of your project, whichever is lower. So, yeah, I guess if you have a really, really big project, just know that it'll be capped at $120,000.
Thank you. And then the other question I have is, thank you for describing the process, starting with the audit. So at what point along that process do you know for sure that you're going to get the rebate? Because I imagine a lot of people are considering doing this now because of the rebate, right? So before you go and install everything, you want to know that you're going to get it.
Yeah. So the way we're qualifying people is from you getting the permit issue date, because we've run into the situation in the past where people get quotes and then we don't. Oops, sorry. Automatic lights. People get quotes and then we don't hear back from them, and then they never proceed with the project. And so since it's a limited time, we will only reserve the funds once you receive the permit issued from the city. And then from there, you'll have 8 months to complete the installation, which shouldn't be an issue. I've seen customers complete it pretty quickly. So from there, you'll have 8 months to install, and then whenever you're done, you'll get the rebate.
Got it. So you get the audit, you get the bids, you essentially kick off the project with the permit, and that's when you know for sure that you're going to have the rebate, and then you have 8 months to complete.
Yes, that's correct. And just to know, these more strict guidelines are only for the boosted heat pump HVAC rebate, because we just want it to be fair to all the customers, since it is limited time. But all of our other rebates, those have been around, they will be around. Those aren't as limited in terms of needing to act with urgency. But this one, we just wanted it to be very clear and very fair for everyone. So we are using the permit issue date as the official, you are qualified and this is the rebate amount you will receive. And if you're considering, you know, say you're looking at two different bids and contractor has given you two different proposals, like different sizes, we can always calculate the rebate for you so you can plan, you know, your costs versus what you'll get in return.
I also want to point out that the boosted incentive, sorry, I'm not on camera. We don't have our little spinning camera thing on right now. Is that, you know, with the goal of this boosted incentive, it's limited time, but we're trying to collect as much data as possible to understand any roadblocks, to see what we can do to streamline processes on the city side, and to really understand the costs. So one of the things we require is for the customers who participate in this pilot to get a like-for-like quote. So what is it going to cost to install a similar piece of gas equipment that you currently have versus an electric heat pump HVAC system? So that is also part of the program requirement. But once you get your permit, that's when you get your milestone payment, right?
Yeah.
Which
So
is
once
the-
you purchase the
yeah.
equipment, get the permit issued, we can give you 20% of the total rebate amount.
Right. To
And
help
then,
you offset
yeah,
the
to
costs.
offset
Yeah.
the upfront costs. And then at the end, we'll pay the remaining 80%. And again, the milestone payments only for the boosted HVAC project.
I have another question. Does any of this, the funds that are allocated here, are any of these at risk or tied to the change in administration in DC and, you know, whatever may or may not happen when the Trump administration comes in?
No, the funding for this program is all through the city. So it's not anything related to like the Inflation Reduction Act or anything with the federal government.
Thank you.
Thank you, Shelby. Yeah, I just wanted to quickly add into that another benefit of scheduling an audit with us will be that you'll also have the report with the list of the equipment requirements that you'd be able to just hand off to contractors for bids. And you'd also be able to see all the available opportunities for other types of rebates that weren't mentioned during this webinar, such as lighting retrofits, kitchen equipment upgrades, and any other piece of equipment that, you know, goes into your utility bills essentially. And so just wanted to highlight that because I know we didn't talk much about our efficiency program, but yeah, it would give you sort of a holistic report of all of the available rebate opportunities that the city has to offer. So I'll throw in the email here to schedule a site assessment. Just reach out and we'll get that going.
Thank you. I'm about to send the email right now. This sounds great.
Great. Yeah. Looking forward to helping out. And yeah, thank you, Steve, Shelby, Hiromi, and everyone else who's still on the call here. I know there's a lot of information, but yeah, exciting times for energy efficiency and electrification, especially with all the heat pump technology that we have.
Very exciting times. Thanks, everyone. Thanks for listening.
Thank you. Have a good day.
Thank you, everyone.
Bye.
So, Jesus,
Bye.
where do you